Chapter 9 is about estimating an athlete's ability using confidence intervals. And in this first section, section 9.1, we're going to discuss the basics of a confidence interval. So, we're going to cover some vocabulary that you'll see throughout this chapter, kind of the general format of what a confidence interval looks like, and then also how we can either change our level of confidence or the precision of our interval by making some changes. So, in chapters 1 through 6, we used an athlete's performance to decide between two competing claims about his or her ability. These claims were called the null hypothesis, which was the claim that we assumed to be true, and then the alternative hypothesis. The process that we used was called a hypothesis test. In this chapter, we're going to use an athlete's performance to estimate their true ability. Unfortunately, we are never able to calculate an athlete's ability as a single number because their true ability is defined as what a player would do in an infinite number of performances under the same conditions. And we've talked about this idea before that really the best thing we can do is use a performance to make a guess at their ability. And ideally, we like to get more data to base that performance on, not just a single game, but maybe a season or several seasons, or perhaps even their entire career. So, what we're going to do in chapter 9 is we're going to calculate what's called a confidence interval, which provides an interval of plausible values for an athlete's ability. A good confidence interval provides a good balance between precision and confidence. And to sort of illustrate the balance between these two, we're going to look at example number 1, where it says, suppose that you want to estimate your teacher's age. So it would be very difficult for you to say, I believe my teacher is 37 years old. What we generally would want to do is say, I feel confident that my teacher is between this age and that age. And so we can decide in advance what level of confidence we want to have. For example, in part A, it says, give an interval in which you would be 100% confident that his or her true age will be included. Well, I have not met your teacher, but I feel very confident that your teacher is at least 18 years old because I know that your teacher had to go through college. And most students don't even begin college until they're at least 18 years old. So I feel very confident that your teacher is at least 18. I'm also pretty confident that your teacher is under 100 years old. I have yet to meet any teacher who teaches until the age of 100. So I would feel 100% confident that your math teacher is between the ages of 18 and 100 years. So notice that even though I feel very confident in this interval, that interval is not very precise. From 18 to 100 is a really, really large range, and it really doesn't give us a lot of information about the teacher. So even though we're very confident that the correct age is in that interval, it's not very precise, so it's not very useful for us. Now, if we want to be more precise, that means that we would have to make our interval more narrow. And to do that, we're not going to be as confident in our guess. So, for instance, if I asked you to give an interval in which you would be about 50% confident that his or her true age would be included, you might say something like 30 to 60. And maybe you'd be basing that on the fact that most teachers at West Ottawa are at least 30 years old because they all, many of them anyway, have at least a few years of teaching experience under their belt. But 60 seems to be sort of the top age for teachers. Some of them are a little older than 60, but many of them retire around that age. So between 30 and 60 might be it's going to be a more narrow, more precise interval, but we're not going to be as confident. Now, for part C, it says give an interval in which you would only be 10% confident his or true age would be included. And this one, maybe if you, especially if you haven't met your teacher face to face, would be difficult for you to make a guess. But you might say, well, I'm going to say that that teacher is probably between 40 and 50 because I feel like many teachers at West Ottawa are in that age range, but I don't know for sure because we are starting to hire a lot more newer teachers. So maybe he or she is under the age of 40, maybe over the age of 50. And again, because my range there is a lot more narrow, I can't be as confident. So, if we want to be more confident, we have to be less precise. And if we want to be more precise, we have to be less confident. And we want to find a balance between those two things. Now, our confidence level describes how much confidence we should have that an interval of plausible values actually contains an athlete's true ability. And in statistics, the most commonly used level of confidence is 95%. So, for instance, what that means is if we calculate intervals for many athletes at the 95% level, that means that 95% of the intervals we calculate would contain their true ability for the athlete for whom the interval was calculated. So, 95% of the time, we would get an interval that captures the right answer, 5% of the time, we would not. In example number two, we're going to look at Seattle Mariners pitcher Felix Hernandez. He has consistently been one of the best pitchers in baseball. In fact, in his first 9 games of the 2015 season, Hernandez had faced 238 batters and struck out 63 of them for a strikeout rate of .265. Based on this, we can calculate a 95% confidence interval for Hernandez's ability to strike out batters. And we're going to say that that interval is from .208 to .322. So, what that interval tells us is that we can be 95% confident that Hernandez's true ability to strike out batters is between .208 and .322. Now, if we were to construct similar intervals for 200 pitchers, about how many of those intervals would you expect to be correct? Correct meaning that includes the pitcher's true ability to strike out batters. Well, 95% of 200 is 190 intervals. So we would expect that 190 of our intervals would be correct and only 10 of them would be incorrect. As the season progressed, what do you think would happen to the width of the confidence interval for Hernandez's ability to strike out batters? Well, as the season progresses, we would have more data. And when we have more data, we can be more precise with our guess. So our intervals should get narrower or be more precise because we have more data. Is it plausible that Hernandez had the ability to strike out 30% of the batters he faced? Explain based on your confidence interval. Oh, by the way, in part C, I would add there that here we're talking about a smaller margin of error. And we'll talk a little bit more about margin of error in just a minute. Now, the original interval that we calculated for part D was .208 to .302, and 30% or zero 0.3 is in this interval. So we would say it is plausible that Hernandez had the ability to strike out 30% of the batters he faced because it was in the interval that we calculated. In example number 3, it says in the 1987 and 88 regular season, NBA superstar Michael Jordan averaged 36.3 points per game at home and only 33.7 points per game on the road for a difference of 2.6 points per game. A 95% confidence interval of the difference in his ability to score points at home and on the road for the regular season is negative 1.2 to positive 6.4. Why do we have negative values here? Well, this negative means that it's possible that there was a game where he maybe scored more points on the road than he did at home, or it would be a season rather, not a home, not a game. So it is possible that we could get a negative value there depending on which value was greater, points scored at home or points scored on the road. So if we interpret that interval, we would say we are 95% confident that the difference in Jordan's true ability to score points at home versus on the road is between negative 1.2 points and 6.4 points. And notice when we're interpreting the confidence interval, we're including the confidence level. We're saying we're 95% confident. We are indicating what is the ability that we're trying to estimate, and we're trying to estimate Jordan's ability to score points, home versus road. And then we're including what the interval is. Now, part B says, does this interval provide convincing evidence that Jordan had a greater ability to score at home? Explain. Well, if Jordan had a greater ability to score at home and we were doing home minus road, that means that we would always get a positive value. So if that was the case, then our confidence interval should not contain negative values and it should not include 0. So in this case, I would say no, because the interval will contain 0, first of all, and 0 indicates that there is no difference in ability. So our interval does not support that claim. Now, when you're writing a confidence interval, they're all going to have basically the same structure. And the structure is going to look like this: a single value estimate plus or minus a margin of error. The single value estimate is a single number that represents our best guess for an athlete's ability, and this number is based on their performance. So it might be a game, it might be a season, it just depends on the context of the problem. The margin of error is the distance between the athlete's performance and their true ability in 95% of the intervals calculated. And you may be familiar with this plus or minus margin of error notation. A lot of times we see that in the news, especially when they're reporting results of a poll or a survey. For instance, when they talk about a president's approval rating or something like that. So we use that plus or minus margin of error notation quite commonly. In example number 4, it says a 95% confidence interval for LeBron James's true ability to make a three-point shot in the 2007-8 season is 0.315 plus or minus 0.049. Interpret this interval in context. That means that we believe, based on one of his performances, which was 0.315, that his ability is about 0.315, and then the 0.049 is the margin of error. So 0.315 minus 0.049 gives us the lower end of that interval, and 0.315 plus 0.049 gives us the high end of that interval. So first I would calculate those. So our single value estimate minus and plus our margin of error, and then we can write our interpretation. We are 95% confident that James's true ability to make a three-point shot is between 0.266 and 0.364. In example 5, it says Ryan Miller was the goalie for NHL's Buffalo Sabres for the 2009-2010 regular season. A 95% confidence interval for Miller's ability to save goals during that season is 0.918 to 0.940. So here we're given the interval with the endpoints, and we want to know what was the observed performance that we based that calculation on, and then what was the margin of error. Well, we know that his observed performance has to be exactly halfway between the endpoints of that interval. So if I add the two endpoints together and I divide by 2, that will give me the middle, which is 0.929. So what we're looking at here is an interval which is centered at 0.929. And then we're going out from there in both directions and going down to 0.918. That's the lower end of our interval, and going up to 0.940. The margin of error is the plus or minus part. So from there, then we can figure out what are we adding or subtracting to go from the center of the interval to the outside edges. And we can either do the top end minus the middle or the middle minus the bottom end. I did the top end minus the middle, and that gave me 0.011. And so that is my margin of error. So we can write that interval as 0.929 plus or minus 0.011. So 2 different ways to write the same interval. Please do assignment 9.1 in your homework packet.